In this video, we're going to review a few topics from 7th grade. It's important for us to remember how sign numbers, which are positives and negatives, work with each other whenever we add, subtract, multiply, or divide. And so in this video, we're going to talk about integer operations, and then we're going to apply that when we evaluate some algebraic expressions. Let's start off with addition. When adding sign numbers, there are two cases to consider. Do the numbers have the same sign, or do the numbers have different signs? If the numbers have the same sign, okay, when we add those numbers together with the same sign, we're going to keep the sign and we will add the absolute values of the numbers. Okay, so if both numbers are positive, our answer is going to be positive. If both numbers are negative, then our answer is going to be negative, and we add them together. So keep the sign, add the absolute values. If the numbers have different signs, then when we add these numbers, we're going to subtract the absolute values of the numbers, and then we will keep the sign of the number with the greater absolute value. Okay, so whichever number has a bigger absolute value, whichever number is further from zero, we will keep that sign. So in example A, we have -30 plus 18. These are different signs, and I have to determine which sign the answer should be. Well, which number is further away from zero? Which has the bigger absolute value? Well, that would be -30. So I know my answer here is going to be negative. And then to figure out negative what, all I'm going to do is subtract the absolute values of the numbers. So the absolute value of -30 is 30. The absolute value of 18 is 18. 30 minus 18 is 12. And so the answer here is -12. In letter B, -11 plus -9, these numbers have the same sign, so I will keep that sign, negative, and I will add the absolute values of the numbers. The absolute value of -11 is 11. The absolute value of -9 is 9. 11 plus 9 is 20. So this comes out to be -20 when we add them together. In letter C, 22 plus -12. All right, different signs again. So I've got to keep the sign of the number with the bigger absolute value. And +22 has the bigger absolute value. So I know my answer this time is positive. And then I subtract the absolute values. All right, the absolute value of 22 is 22. Absolute value of -12 is -12. 22 minus 12 is 10 for our answer. Finally, letter D, -17 plus 17. These numbers are opposites, okay? They're the same distance from zero, and opposites add up to zero for our answer. Let's review subtraction of sign numbers now. All right, when you're subtracting sign numbers, you should first change the problem into an addition problem. In order to change a subtraction into an addition problem, you will keep the first number the same, all right, keep the sign of the first number, and then you will add the opposite of the number that was being subtracted. Once you have done this, then you have an addition problem and just follow your rules from addition. Okay, so for example A, we have 10 minus 3. Now that's a very straightforward answer. We know the answer to that, but I just want to practice changing it into an addition problem. We keep the sign of that first number, so that's going to stay as 10. But then we're going to add the opposite of 3, which is -3. 10 plus -3. And now we can add those together. 10 plus -3 is +7. All right, how about with 9 minus 20? Well, let's first make it an addition problem. Keep 9 and then add the opposite of 20, which is -20. Now these numbers have different signs. I keep the sign of the number with the bigger absolute value, which is -20. And then I subtract the absolute values because they're different signs. The absolute value of -20 is 20. Absolute value of 9 is 9. 20 minus 9 is 11. So we get -11 for our answer this time. And then with letter C, 6 minus -2, change it to addition first. Keep 6. Add the opposite of -2, which is +2. 6 plus 2 is 8. All right, so that's the key to getting your good answers when you're subtracting. Just change it into an addition problem first. What if we're adding or subtracting more than two numbers together? Well, in these examples, we're just going to rewrite any subtractions as additions, and then we're going to go step by step until we have evaluated our expression completely. In letter A, we have 7 minus 10 plus 2 minus 5 plus negative 3 plus 11. All right, I see two subtractions that I'm going to rewrite as addition first. So first I have 7 minus 10. I'm going to keep 7. And then instead of subtracting 10, I'm going to add the opposite, which is negative 10. I'm going to keep plus 2 because it's addition. And then instead of subtracting 5, I'm going to add the opposite, which is negative 5. Then I'll add negative 3. I can keep that the same. Add 11. It's addition. Keep that the same. Now let's just go step by step until we have our answer. 7 plus negative 10, well, that's negative 3. All right, keep the sign of the number with the bigger absolute value and subtract the absolute values. Plus 2 plus negative 5 plus negative 3 plus 11. And then negative 3 plus 2 is negative 1 plus negative 5 plus negative 3 plus 11. Negative 1 plus negative 5, they're same signs. That gives me negative 6 plus negative 3 plus 11. Negative 6 plus negative 3, again, same signs. Add those absolute values. Negative 9 plus 11. And then finally, negative 9 plus 11, positive 2, since 11 has the bigger absolute value, and I subtracted the absolute values because they were different signs. Similarly, in letter B, negative 8 plus 9 minus 2 minus negative 5 plus 3 minus 10. Let's change subtractions to additions. Now, it starts out negative 8 plus 9. It's already addition, so I'll keep it. And then instead of subtracting 2, I'll add the opposite, which is negative 2. Instead of subtracting negative 5, I'll add the opposite, which is positive 5. Keep the addition, plus 3. And then instead of subtracting 10, I'll add the opposite, which is negative 10. Now let's take it step by step until we have our answer. Negative 8 plus 9, different signs. That's positive 1, plus negative 2, plus 5, plus 3, plus negative 10. 1 plus negative 2, again, different signs. It's going to be negative this time. Negative 1, plus 5, plus 3, plus negative 10. Negative 1 plus 5, again, different signs. Positive 4, since 5 has the bigger absolute value. Plus 3, plus negative 10. 4 plus 3 is 7. And finally, 7 plus negative 10, different signs. Negative 10 has the bigger absolute value, so we're going to get negative 3 as our final answer this time. Now we'll review product and quotient rules for sign numbers. So this is when you're multiplying or dividing positives and negatives. If your two numbers involved in your multiplication or division problem have the same sign, so they're both either positive or both negative, then the result to your problem will always be positive. Okay, but if the two numbers in your multiplication or division problem have different signs, so you have one positive and one negative, then your result will be negative. So just pay attention to how many negatives you have in the problem. Letter A, negative 8 times negative 10. Both numbers are negative, so I know that when I do the product here, I'm going to get a positive answer, and 8 times 10 is 80, so that comes out to be positive 80. In letter B, 7 times negative 5, the numbers have different signs, so I know that my answer will be negative, and 7 times 5 is 35. Letter C, negative 40 divided by negative 8. Both numbers are negative, so I know my quotient will be positive. 40 divided by 8 is 5. Letter D, 48 divided by negative 6. Different signs, so the quotient's negative this time, and 48 divided by 6 is 8. Letter E, negative 9 squared. All right, the negative 9's in parentheses, just like that. So this means to do negative 9 times negative 9. A negative times a negative is positive, and 9 times 9 is 81. Letter F, negative 5 times 12, different signs, so the product is negative, and 5 times 12 is 60. Letter G, negative 45 divided by 5. This is a fraction, but a fraction is division. Different signs, so I know that my answer is going to be negative, and 45 divided by 5 is 9. And finally, in letter H, negative divided by negative will be positive this time. 49 divided by 7 is 7. So again, just pay attention to how many negatives that you have in the problem, and that will help you determine the sign of your answer. When we're simplifying numerical expressions, it's important to remember to follow the order of operations. All right, with the order of operations, we're going to evaluate any expressions within grouping symbols first. Grouping symbols. Okay, so if you have any operations inside of the following symbols, evaluate those first. All right, the most popular grouping symbol would probably be parentheses, which we know looks like that. Brackets, which are just like parentheses, but they're more squared off. All right, braces, which are these squiggly ones that are fun to draw. Or absolute value bars, which look like that. Okay, if you have any operations inside of these symbols, then that's the first thing that you need to do. After we take care of grouping symbols, we'll look for any exponents, and then we'll move on to multiplication or division. We always work in order from left to right. So whichever one comes first, that's what we'll do first. And then the last layer is addition and subtraction, again working from left to right. So if the addition comes first, do that first, or if the subtraction comes first, do that first. So let's look at a few examples underneath. Letter A. -8 plus -3 times, in parentheses, -2 plus 4 squared. I'm looking for grouping symbols first, any operations in the grouping symbols, and I see here in my parentheses I have an addition problem. I'm going to do that first. So I'm going to bring down everything I'm not using, -8 plus -3 times. In the parentheses, -2 plus 4 is 2, and then we have to square that result. All right, I don't have any more operations in grouping symbols, so now I'm going to move on to my exponents, which I find right here. I have to square 2. 2 times 2 is 4. So I'm going to have -8 plus -3 times 4. Now I'm looking for multiplication or division, and I see here at the end I've got multiplication. -3 times 4 is -12. So this is -8 plus -12. And the last thing I'm going to do is add these numbers together, which will give me -20 as my final answer. Letter B, we have 3 squared plus -2 cubed plus the absolute value of -6 plus 2. Again, look for those grouping symbols. I have absolute value bars in this example with an addition problem inside, so I'm going to do that addition first. So we have 3 squared plus -2 cubed plus the absolute value of, well, -6 plus 2 is -4. All right, so now we can evaluate what that absolute value is going to be since it's now just a single number. So this will be 3 squared plus -2 cubed plus the absolute value of -4 is 4, since it's 4 units from 0 on the number line. Now I'm going to take care of any exponents. Here I see 3 squared, 3 times 3 is 9, plus -2 cubed. -2 cubed is -8, plus 4. Now I'll work in order for multiplication or division. I don't see any of those here. Addition and subtraction, I do see addition, so I'm going to go right in order. 9 plus -8 is 1, and 1 plus 4 is 5. Finally, in letter C, I have this fraction here, and a fraction represents division, but I can't do this division until I know what my numerator is and what my denominator is. So I'm going to work step by step in my numerator and denominator. Starting in the numerator, I have grouping symbols with 9 minus 4 inside. We'll evaluate that to get 5. So the numerator becomes 35 divided by 5. And now in the denominator, I have subtraction, multiplication, and addition. I have to do this multiplication first. 7 times 2 is 14, so it's 20 minus 14 plus 1. Moving back into the numerator, 35 divided by 5 is 7. And then in the denominator, I go right in order with my addition and subtraction. The subtractions first. 20 minus 14 is 6. All right, numerator's done, but the denominator I have to do 6 plus 1, which I know is 7. And now I'm at the last step where I can do 7 divided by 7 for a final answer of 1. Now that we've had a good review of the rules for adding, subtracting, multiplying, and dividing integers, let's see if we can apply that to evaluating algebraic expressions. Whenever we evaluate algebraic expressions, the first thing we're going to do is substitute in the values of the variables. Once we do that, then I'm going to have just numerical expressions, so I'm going to follow the order of operations until I've evaluated the expression completely. So let's take a look at our first example, negative 2ab plus 3b plus 4. Over here I said a was 5 and b was negative 6, so I'm going to substitute these values into their appropriate places. So I'm going to have negative 2 times a, which is 5, times b, which is negative 6, plus 3 times negative 6, plus 4. Now I'm going to go ahead and use my order of operations. I don't have any operations in grouping symbols, and I don't have any exponents, so I'm going to look for multiplication and division. And I do see multiplication, so I'm going to do negative 2 times 5, which is negative 10, and then bring everything else down. Okay, and then here I have negative 10 times negative 6, which is 60. Bring everything else down. And then I have one more multiplication here. 3 times negative 6 is negative 18, so I'm going to have 60 minus 18 plus 4. Now I'm at the addition and subtraction stage, again going from left to right. 60 minus 18 is 42, and 42 plus 4 is 46 for that expression. In example number 2, negative 3xy squared. Let's substitute in negative 4 for x and 3 for y. So this becomes negative 3 times negative 4 times 3 squared. Using order of operations, no operations in grouping symbols, but I do have an exponent here. 3 squared, 3 times 3 is 9, so we have negative 3 times negative 4 times 9. And now negative 3 times negative 4 is 12, and then 12 times 9 is 108. In example 3, we have 3ab divided by 3b. A is negative 3, while b is 5. Let's substitute that in. 3 times negative 3 times 5 over 3 times 5. All right, in the numerator, I'm going to first do 3 times negative 3, which is negative 9. So it's negative 9 times 5 divided by 3 times 5, which is 15. All right, and then I'll bring this over here. All right, negative 9 times 5 in the numerator is negative 45, which I will then divide by 15. All right, and a negative divided by a positive is negative. 45 divided by 15 is 3. So negative 3 is the answer to that expression. In number 4, we have the product negative 2a, and the answer to that, we're going to square it. A is negative 3. So I'm going to have negative 2 times negative 3, and then I'll square the answer. Since this operation is in the parentheses, I'm going to multiply first negative 2 times negative 3 to get 6, and then I'm going to square 6. 6 times 6 is 36. Notice over here, looks similar to this example, but now I don't have any parentheses here. I'm still going to substitute in negative 3 for a. So I'm going to have negative 2 times a squared. A's value is negative 3, so I'm going to put that in parentheses and then square it. All right, and now that this is in parentheses here, this means I have to do negative 3 times negative 3, which is a positive 9. So it's negative 2 times 9, which comes out to be negative 18. In example 6, we have 4 times the sum x plus y minus 7. X is 5, y is 3. Let's substitute. 4 times in parentheses, 5 plus 3 minus 7. And now use order of operations. We'll add 5 and 3 in the parentheses to get 8. 4 times 8 minus 7. 4 times 8 is 32. And then subtract 7 for 25 as your evaluated answer. 4 times x plus 3 times y. X is 2, y is negative 7. Substitute first. 4 times 2 plus 3 times negative 7. And now we'll multiply before we add. 4 times 2 is 8, plus 3 times negative 7. 3 times negative 7 is negative 21, so we have 8 minus 21. And now when we subtract those, that is going to give us an answer of negative 13. Number 8. Again, this looks similar to what we had here, but notice now we have parentheses around the x plus 3y. X is still 2 and y is still negative 7. Let's substitute first. 4 times in parentheses, 2 plus 3 times negative 7. Now in your grouping symbols, in your parentheses, you have addition and multiplication. You have to multiply before you add. So we're going to have 4 times in parentheses 2, and then 3 times negative 7 is negative, so minus 21. Now we'll do 2 minus 21 in the parentheses. So we're going to have 4 times 2 minus 21 is negative 19. And now we can do 4 times negative 19. A positive times a negative is negative. And 4 times 19 is 76. So we get negative 76 for our answer here. All right, and then the number 9, 4x squared plus 3y. Again, x is 2 and y is negative 7. 4 times 2 squared plus 3 times negative 7. Exponent first, 2 squared is 4, so 4 times 4 plus 3 times negative 7. 4 times 4 is 16. 3 times negative 7 is negative 21, so it's 16 minus 21. And when we subtract, we get an answer of negative 5. So again, make sure that you show the substitution as your first step, and then just follow your order of operations step by step until you have evaluated completely. Let's do a few more expressions just to make sure that we've got the hang of it. In our 10th example, n plus 10 divided by c minus n. N is 8 while c is 14, so the numerator is going to be 8 plus 10, while the denominator is going to be 14 minus 8. Okay, so if we take a look now at the numerator, all right, so again, n plus 10, 8 plus 10 becomes 18. Denominator c minus n became 14 minus 8. 14 minus 8 is 6. And then 18 divided by 6 at the end gives us an answer of 3. Number 11, 50 minus d divided by p plus 3. D is 5, p is 6, so let's substitute those in. 50 minus d is 5, so 50 minus 5, divided by p plus 3. P is 6, so 6 plus 3. In the numerator, 50 minus 5 is 45. In the denominator, 6 plus 3 is 9. And now we can divide 45 by 9 to get an answer of 5. All right, in number 12, it says to describe and correct the error if x equals 7. So looking at the work that they did here, here's the original expression, 5 plus 4x. X was 7, so they substituted that in here. Then they added 5 with 4 to get 9, and then 9 times 7 is 63. It looks okay, except this person added before they multiplied. So that's the error. Addition before multiplication. We know that we're supposed to multiply before we add. So let's see if we can fix the error. Okay, so this was good. Substituting was fine. But now over here, let's go ahead and I'm going to draw an arrow over. All right, I'm going to multiply first. 4 times 7 is 28. So this line should say 5 plus 28. And now I can add those together, 5 plus 28, to give me a correct answer of 33. In number 13, again, describe and correct the error if x is equal to 3. So the expression was negative 4 times x squared. They filled in x with 3, negative 4 times 3 squared. And then they did negative 4 times 3 to get negative 12. And when you square negative 12 times negative 12 is 144. The problem here, though, is that this person multiplied before evaluating the exponent. With order of operations, we're supposed to do that exponent first before we multiply. So the error was multiplication before evaluating the exponent. So again, let's see if we can correct the error. So again, that's the expression, that's the substitution. And then here, the first thing I'm going to do is 3 squared. 3 times 3 is 9, so this line should say negative 4 times 9. And then when I multiply negative 4 by 9, I get negative 36. So again, just pay close attention to the order of operations. That way you're going to make sure that you evaluate completely and correctly. And then at the bottom is just a reference sheet on the rules for working with integers. You have your addition rules, same in different signs. You have your subtraction rules, change the subtraction to addition first. And then you have your multiplication and division rules at the end.